Welcome to this discussion on dimensional analysis. The first thing you need to do when tackling a problem of this sort is to read the question. Here it says during autumn 20 leaves fall from a tree per minute. Examining that sentence shows you a relationship between the 20 leaves and the per minute. So whenever a relationship is given, we know that we can turn this into an equivalent statement. So I just highlight that. And then it says weighing an average of 0.347 grams per leaf. So here again we have a relationship. Here's the word per. So I'm going to highlight that when we have a relationship. How many bags of leaves will be collected after 7 days if each bag can hold 5 kgs of leaves? Do we see another relationship? Yes, we do. Each bag can hold 5 kgs of leaves. What do we have left over? That's very important. We have the figure 7 days left over. With the leftover information, that's where we're going to end up starting our dimensional analysis. So here we have 7 days over 1. Now here you see we have a unit of time. Let's examine our 3 equivalent statements. The first one you see has a unit of time, but it says per minute, and here we have days. So in order to use this equivalent statement, we have to convert from days to minutes. Don't use any shortcuts. 1 day contains 24 hours. And 1 hour contains 60 minutes. Now you see we have minutes at the top. Our next conversion factor, now that we want to use this equivalent statement, we'd like the minutes at the bottom, per minute. Remember, with an equivalent statement, it doesn't matter which way round you use it. It just needs to flow from your starting point. That's why we have minutes at the bottom here. Minutes could also be at the top, depending on the flow of the calculation. So at the top here we have 20 leaves. Now we can see our days cancel, our hours cancel, our minutes cancel, and we've got leaves at the top. If we want to carry on now and we examine our conversion factors, here it's talking directly about leaves. Doesn't matter whether it's plural or not. 1 leaf weighs 0.347 grams. Let's do a little bit of cancelling. Leaf and leaf. Now we've got grams. That's unit of mass. Our final equivalent statement also has a unit of mass, but it's in kilograms. So before we can use it, we need to convert this from grams into kilograms. So that means we're going to have grams at the bottom, kilograms at the top. The prefixed unit, so that's the base unit, with a letter written in front of it. We usually put the 1 there, and then the 10 to the power of 3 over there. So now we can see grams are going to cancel out, and we've got kgs at the top. What does that mean? It means we must have kgs at the bottom. And if we look again at the equivalent statement, each bag, so 1 bag, can hold 5 kgs of leaves. And when you do that on the calculator, you end up getting the answer of 13.99 bags. Roughly 14 bags. Now, if we have to go and evaluate the significant figures, we need to look at each conversion factor in turn and look at its influence on the significant figures. This is a known conversion factor. It won't influence. Again, the same thing here. This was counted by a human being, so there's error involved. 20 leaves, that holding only 1 significant figure. Here again, measured by a human using an instrument, 3 significant figures. This won't influence significant figures. Here again, counted by a human, each bag weighing 5 kgs, the measurement, only one significant figure. So if our answer had to have one significant figure, that is the first significant figure, will we round up or stay the same? We definitely stay the same. 10 bags is the answer with only one significant figure.